So there are like a lot of vocabulary words today. So I'm not going to write down all of them. All I'm going to tell you is the definitions when we're going by them. So if you're like, I need to have these definitions written down, they should all be in your book. Okay? So we are on page 62 today. And we are talking about rates, ratios, and proportions. A ratio is a comparison of two quantities by division. Alright? And a proportion is when two ratios are equivalent. Equivalent means equal. So, the first problem we're going to do today is example 1. And on lessons like this, where we're doing a lot of story problems, it might be helpful to follow along in your book, because then the video won't be as long, and maybe some of you will enjoy it more. Probably not, though. So, the ratio of faculty members to students at a college is 1 to 15. So we have faculty to students is 1 to 15. Okay, the colon is read as is, or 2, I'm sorry. Faculty to students is 1 to 15. So since faculty is first, the first number, 1, applies to it, and since students is second, the 15 applies to students. There are 675 students, so we have 675 students, and we want to know the number of faculty. So we are looking for the faculty. Okay? It's like the teachers and stuff. So, first of all, we're going to set up a proportion. Okay? So we have faculty over students equals 1 over 15. Okay? So, now what we can do is that we know there are 675 students. We can replace students with 675. And that's going to equal 1 over 15. Okay? And then all we have to do is cross multiply. When you have proportions, you cross multiply. You don't multiply straight across. So, f times 15 is 15f. And 675 times 1 is 675. Then we solve for f by dividing by 15. And the answer is 45. So there are 45 faculty members at that college. So on that problem, if they would have given us the total number of faculty members, we would have put it in for F for faculty and then solved for S. Alright? So the next problem is talking about hot dog contests, which I think are disgusting. Anyways, we have 53 and a half hot dogs. Oh, that is a lot of hot dogs. I cannot write today. In 12 minutes, sick. So this man, I can't pronounce his name, decided he was going to eat 53 and a half hot dogs in 12 minutes to win a contest. We are finding the unit rate. Unit rate is something per one of something, like miles per hour, or in this case, hot dogs per minute. Okay, so whenever you see the word unit rate, it is per one of something. One of something. Miles per gallon. Price per can of pop if you bought a 12-pack of pop. Okay, so since hot dogs comes first in our little sentence, we're going to put hot dogs over minutes. Okay, and we want to know how many hot dogs this man ate in 1 minute. Okay, that's what it's asking. So we know that we have 53.5 hot dogs. And he can eat that in 12 minutes, right? And we are like, all right, well, how many of those did you eat in 1 minute? So again, what we're going to do is we are going to cross multiply, and we get 12x equals 53.5, and then we're going to solve for x by dividing by 12, and x equals 4.46 hot dogs. So not even 4.5, 4.46. All right, so next problem is using dimensional analysis. So let's read the problem. It says that a large adult male human has about 12 pints of blood. Use dimensional analysis to convert this quantity to gallons. Dimensional analysis is just a fancy word to convert. Okay, so what we are doing is we want to do 12 pints to gallons. All right, and what I always do is I always say to put what they give you over 1. So this is the given, so you put 12 pints, and you actually do need the unit with it, so 12 pints over 1, and then you are trying to get to gallons. Well, if you know how your units work, you know you have pints to quarts to gallons. Now the book shows this in 2 steps. I'm going to show it in 1. So what we want to do is we have 12 pints. This shows you right here, if we know we are going pints to quarts to gallons, that we are going to have 3 fractions. Okay? So that's easy enough. So the first thing we're going to do is we need to get from pints to quarts. We have to eliminate pints. So pints needs to go down here. Okay, and quarts needs to go up here. So if you are changing to quarts, quarts is going to go to the top, and what you're changing from goes on the bottom. So there are 2 pints in a quart. Okay, so now we're going to go from quarts to gallons. So what we are changing to is going to go in the numerator. What we're changing from is going to go in the denominator. There are 4 quarts and 1 gallon. All right, and now what we need to do is we need to cancel. We can cancel the pints. We can cancel the quarts. We are switching to gallons, so I'm left with gallons, so I can put that I have gallons down here. And then I have to divide and multiply and all that good stuff. So 12 times 1 times 1 is 12. 1 times 2 times 4 is 8. And when you do 12 divided by 8, you get 1.5 gallons. So 12 pints of blood is 1.5 gallons of blood. So we're going to do another one of those now. It is 3B. The dwarf seahorse Hippocampus zos, I can't pronounce that, swims at a rate of 2.68 feet per hour. So we have 52.68 feet per hour. Use dimensional analysis to convert his speed to inches per minute. Okay, so this is what they give us. This here is our given. I don't know why my little pen's not working today. So we're going to put that over 1, just like we did before. 52.68 feet over 1 hour in this case, because it's feet per hour. All right, and now what we have to do is we want to get to inches per minute. So what we're doing is we're changing our feet to inches and our hours to minutes. Okay, so we're going to have an additional 2 fractions. That's what that tells us. The first thing we're going to do is we're going to change feet to inches. So what I'm changing 2 inches, that goes on top or in the numerator, and what I'm switching from goes in the denominator. And I know there are 12 inches for every 1 foot. Now, since I'm going to hours to minute, I have to look back at the original, and I am changing from hours to minutes. Okay? The reason this switches is because I need to cancel the hours out to get to minutes, so they have to be in opposite places. So I have 1 hour equaling 60 minutes. So whatever you're changing from just goes in the opposite place, because you need to be able to cancel those out, because you no longer want feet, you want inches, and you no longer want hours, you want minutes. And then you multiply and divide and all that good stuff. So we have inches over minutes for our dimension, and we do 52.68 times 12, and that gives us a number, and it's over 60. Okay, and when you divide 52.68 times, so we're just going to put 52.68 times 12 here, because we're going to have to multiply, but I don't have a calculator. So when you multiply and then divide, you get 10.536 inches per minute. Okay? So we'll do more of those in the later part of this video. Solving proportions. It's going to be a little bit longer of a video. Sorry, it's a long lesson. Proportions, we have 5/9 equals 3/W. The first thing you do is you cross multiply. You should know that, I feel like. So we cross multiply, and we get 5W equals 9 times 3, which is 27. You solve for W, so you divide by 5. These cancel, and W equals 5 2/5, or 5.4. I honestly would rather you leave it as a mixed number like this than change it to a decimal. But do what you want. The next one it gives is the following. 8 over x plus 10 equals 1 over 12. Now, whenever you have 2 terms in either numerator or the denominator, put them in parentheses so that you remember that you are doing the distributive property. Okay? So, this time the distributive property is easy because we're just doing 1 times x plus 10. So, equals 8 times 12. And this is just showing cross multiplication. We didn't do it on the other one just because there was... In this one, you didn't have to do the distributive property. You just had to do 5W equals 27. But when you have to do distributive property, sometimes it makes it a little bit easier to write it out, because then you remember you have to do the outside number by each term. And when it's not 1, it's not always as simple. And what's that equal? 96. So then you subtract 10 from each side. And x equals 86. And there's your answer. So the next one we have is scale drawings. This is the last examples we're going to do. On the map, the distance from Chicago to Evanston is 0.625 inches. What is the actual distance? So we are going to do the following. We are going to have the equation map over actual. Okay, it's always going to be map over actual. So, on the little map beside our problem, it tells us that 1 inch equals 18 miles. Okay, so the map is going to show us 1 inch. The actual distance of that is 18 miles. Okay, the problem tells us that on the map, the distance is 0.625. So we're going to replace, just like we did in the first example back 15 minutes ago, we're going to replace map with 0.625, and we're going to put that over the actual. We can replace that with x equals 1 over 18. Then we're going to cross multiply, and we're going to get x equals 0.625 times 18. Okay, and that actually just equals 1 times x. That equals 11.25. Now again, you don't necessarily need to do that step, but that just shows you what you're multiplying. The next one is just a little bit opposite. The actual distance, we're still going with 1 inch equals 18 miles. And this one says the actual distance between North Chicago and some town is 4 miles. What is the distance on the map? So we're still going to do map over actual. What the heck? There we go. Equals, and the map says 1 inch over 18 miles. But the problem says that the actual distance is 4 miles. So this time, instead of replacing map with something, we are going to replace actual with 4, and that still equals 1 over 18. Then I'm going to cross multiply, and I get 18x equals 4 is fine. Divide by 18, and we get x equals 2/9, which is about 0.2 miles. Okay, so that's what we got. If you would like to stay and do some more problems, that's fine. If you don't, you can go on Canvas and see what the lesson is for the assignment. Sorry that video is so long. So let's see. To keep going, if there's any of you who want to keep going, the ratio of games won to games lost for a baseball team is 3-2. So 1 to lost is 3-2. The team won 18 games, and we want to know how many they lost. Okay, so we have 1 over lost equals 3/2. We know they won 18 games, so we're going to substitute W with 18 over lost equals 3/2. Then we can cross multiply, and we get 3L equals 36. Divide by 3, and the amount of games they lost was 12. Whew. Okay, next problem. Oh man, that's not what I wanted to do. So next problem is the following. I changed my color. Oh, purple's not there anymore. That's a sad day. Okay. Anyways, Corey earns $52.50 in 7 hours. $52.50 in 7 hours, and we want to know how much he earns per hour. So this is unit rate. So all we have to do is super easy. Whoa, what just happened? We just have to do, okay, he makes 52.50 in 7 hours. How much does he make in 1 hour? Which really all you have to do is divide 52.50 by 7. But if you want to go the whole route, you get 7x equals 52.50. You divide by 7. And x equals 7.50. So he makes 7.50 per hour. I remember back in the day when I made $7.50 per hour and I thought I was living large. Let's see. A cyclist travels 56 miles in 4 hours. So 56 miles in 4 hours. And they want us to change that to feet per second. Ooh. This one's a little bit harder. Okay, so this here's our given. So we have 56 miles. I'll try to fit this all in one line over 4 hours. Okay, the first thing we're doing is we change miles to feet. And that's not that big of a deal. Miles to feet. But then we have hours. We can't just go hours to seconds, so we have to go hours to minutes to seconds. So, first thing we're going to do is do miles to feet. So, we are switching to feet, so we're going to put that here. And we're coming from miles, so we have to put that in the opposite place, so it cancels. There are 5,280 feet in 1 mile. This is very important to know your dimensions. The next thing we're going to do is we are going to change hours to minutes. So we need to cancel the hours, so it's got to go in the opposite place. And there are 60 minutes in 1 hour. And then we have to go from minutes to seconds. So we want to get rid of the minutes, so it has to go in the opposite place to seconds. And there are 60 seconds in 1 minute. That wasn't that long, I guess. So now we need to cancel. We can cancel our miles. We can cancel our hours. We can cancel our minutes. And now we are left with feet and seconds, which is what they told us to switch to. So if you have a calculator, which I don't, you could multiply this out, but I'm just going to do 56 times 5,280 over 4 times 60 times 60 feet per second. And I am actually fine if you just leave it in that form. However, if you want to know exactly, you could multiply that out and you know it's 20.5 feet per second. But you don't have to go to that extent. That's fine. Let's see. I feel like proportions are something you should know how to do. Because you start learning those in like 6th grade math or maybe even 5th grade math. So we're going to do a scale model of a heart, and I'm not going to draw a heart because I can't, but it says is 16 feet long. The scale is 32 to 1. How many inches long is the actual heart? So we have the scale equaling 16. Is that right? Yeah, 16. And then the scale is 32 to 1. Okay? So we are going to have the heart over the actual, because it's not map over actual, it's heart over actual. And we are going to have This is going to be your scale. Oops, that's supposed to say scale. And this is going to be your actual. So, we get 32 over 1. And then in for the scale, we put 16. This is not working out. How is it 6 inches? Oh, okay. 16 over x equals 32 over 1. We cross multiply, and you get 32x equals 16 divided by 32 divided by 32, and x equals 1/2. Now that is 1/2 foot because the scale was in feet, okay? So 1/2 foot equals 6 inches. So that's how we got that. That was an interesting problem because it didn't really give you a picture or anything. So you still do the heart, or we're doing heart this time and not map over actual, equals 32 because it said the scale of the human heart, or the scale model of a human heart. So you can assume that the 32 is the scale and the actual is 1. Okay? So let's see, if you watched all this and you're like here like almost a half hour later, awesome. And I will give you extra credit if you have, well, let's see, what word do I want to? Well, it's Labor Day and I'm being lazy. Oh, I'm not being lazy today, but I should have been. So if you write the word lazy on your paper and don't tell anyone else, one person last time got extra credit. I will give you a 1/4 point of extra credit, which is actually quite a bit when your homework is only worth 2 points. Have a good day.